lithium is mined in Australia and Chile, Argentina, Africa, but goes to China to be processed and turned into materials for batteries. Cobalt comes from Democratic Republic of Congo, but again, goes to China pretty much. And nickel from Indonesia, where it's mined and also processed, then goes to China. So China effectively sucks in all these raw materials and turns them into useful products. And this also drove Chinese companies to invest all over the world in mining projects to secure supplies of raw materials. And this has had big geopolitical implications. You have a situation where China controls a lot of these supply chains, processes a lot of these minerals, and then produces a lot of the batteries. So if you're looking at who has power in the clean energy world, it's clearly China.
A warm welcome back to Decouple. Today I'm joined by Henry Sanderson. He's a former journalist at the Financial Times, reporting on commodities markets with a focus on metals and minings, and more recently the author of Volt Rush, the winner's curse in the race to go green, which is the book that we are going to discuss today. Henry, welcome again to Decouple.
Thanks for having me on.
So I really enjoyed this book. It had an almost sort of Daniel Yergin flavor in terms of tracking the development. You're pretty focused on batteries in this book, but focusing on and traveling through the history of the development of that technology, some very colorful personalities along the way, some of the impacts of this energy transition, the mining, the human rights impacts. Really fantastic book. I think I'd like to start off chatting a little bit about the kind of use cases of batteries as they've moved through time. But first off, let us get a chance to get to know you a bit better. I gave you a pretty anemic introduction there.
No, thanks for having me on. I think the introduction was perfect. So I was a journalist for all my career, and I was in China for 7 years, working there in Beijing. Then came back, joined the Financial Times, covered commodities. And that's what spurred me to write this book. It does focus a lot on batteries, and I can talk about why if you want me to do that. But they're one of the key sort of enabling technologies of the energy transition, because if you think about what's oil used for, cars, trucks, transportation, so batteries can help decarbonize that sector. And then you've got helping renewable energy integrate to the electricity grid, which is the fundamental problem we face in terms of decarbonizing electricity, is how do you build a system around renewable energies? And batteries are key to that, because renewable energies are by their nature intermittent. And then you've got batteries that people buy for their homes, that they may use to store energy in their homes from their own solar panels. And then eventually we could see electric cars integrating with people's homes. And then there's businesses that buy their own batteries and solar, data centers, etc. So it really is a really key technology. And I felt hadn't been written about as much as perhaps solar and wind and other clean energy technologies. And I write about the supply chain behind it. But yeah, thanks. Great introduction.
Yeah, I mean, batteries have been a bit of a kind of missing piece of this podcast. We're over 300 episodes into deep diving topics of energy, supply chains, geopolitics. We have covered energy storage more thematically, but great to have a chance to talk to someone with some expertise in the battery field itself. Deep diving, the development of batteries, the history is not that old. I mean, going back to Volta in the 1800s, one thing that jumped out to me, I know your book sort of starts off with this sort of early competition between internal combustion engines, even steam-powered cars and electric vehicles. But just prior to that, our first global telecoms network was battery powered, right? Like we didn't have grid power to run telegraphs. So I'm not sure if that's the starting point you want to jump off on, but I thought that was fascinating. But certainly happy to jump into the first electric vehicles.
Yeah, I mean, I think batteries have a relatively long history, going back, as you say, to Volta, who made the first battery with metals and sort of cardboard in between them. And then you're right, batteries were the source of power and electricity before the first power stations came along, before Thomas Edison in Pearl Street, New York, and then elsewhere. So batteries were the source of electricity, and the lead acid battery was invented in middle 19th century, and that was a key development. And then what we saw was really the sort of lead acid battery industry, and there was a lot of swindles and sort of rogue types and entrepreneurs, and a lot of bad dealing. And that's why Thomas Edison said, was very negative about the battery industry in the late 19th century, saying that full of people who weren't trustworthy. And then you had batteries being used in cars, because at the time, in sort of late 19th century, early 20th century, it wasn't clear which technology was going to dominate. So you had the steam cars, electric vehicles, and internal combustion vehicles on the road. And it looked like for a brief period of time, electric vehicles would win. They weren't noisy and polluting. And you got to remember, people at that time lived with the terrible pollution of horses in the cities, right? The manure, the smell. So internal combustion didn't actually seem, that promising an option. And what's so fascinating is Edison himself, who's such a famed inventor, worked on trying to come up with a better battery than the lead acid battery, which kind of leaked and didn't have great range. And he spent many, many years working on this. And he even teamed up with Henry Ford to create a mass market electric vehicle. And they got so close, right? Before the First World War, they got so close. And he, there was a lot of excitement. I think people would have supported a Edison Ford car, but Edison's battery wasn't quite there yet. He was a bit behind, and people had also got kind of tired of all the hype and promise of batteries at the time. And then the Model T and the internal combustion engine just went from strength to strength, and the starter motor was a key invention. But then batteries and lead acid batteries had a role then in cars, right, and which they have up to the present day. Lead acid batteries not really talked about much, but they're in cars, right, to help them start. So batteries have never gone away. But I think until the lithium ion battery came along in 1980s, commercialized in 1991, the other batteries didn't really have the performance requirements to really enable electric vehicles. And I can talk about what happened after the lithium ion battery. But I think looking back to the history, it is so fascinating that we had this period of time where electric vehicles were on the streets of New York, were considered a viable technology. Battery swapping was something that was tried out at the time. And there was a notion that you could have electric vehicles for shorter distance and internal combustion for longer distances. But internal combustion just sort of swept everything away. And that's one of those historical turning points.
Yeah, one interesting factoid was that the world's land speed record in 1899 was set by an electric vehicle, the Jamais Content. So, obviously quite boutique, but high performance capacities even then. What were some of the main sort of constraints at this time? Aside from the inferior battery chemistry, which we now seem to have in large part overcome more recently. What were some of the reasons why things floundered? You mentioned, it's interesting, I'm an emergency physician by practice, and there's actually a fracture pattern in the wrist related to that hand crank that was required in early combustion vehicles, radial styloid fracture. It has an eponym, which I'm just blanking on. I think it's the brakeman's hand or the whatever else. And so, I understand that was a big reason why particularly women drivers were interested in electric vehicles. But yeah, let's just deep dive that a little bit more, because it's such a fascinating moment in history. I guess some of the key limitations, again, beyond battery chemistry, as to why things floundered.
Yeah, so I think also the charging infrastructure, the electricity grid wasn't quite there yet. And you've got to remember, at this time, most people in America, and especially in the countryside, didn't have electricity, weren't connected to the grid. So there just wasn't the sort of charging infrastructure available. And also one of the mysteries is the electricity grid, the utilities. Electric vehicles were a promising source of demand for them, right? Because if you think about them generating electricity all this time, they needed the demand, the load, which wasn't really there. So there were some moves by the electric industry, electric utilities, to kind of think about electric cars and even promote them or buy them, but they weren't quite as proactive as was necessary, perhaps, to build out the charging infrastructure. And I think internal combustion engine, I think when you went touring in the countryside, I think there were always farms where you could get fuel and fill up, etc. Whereas I think you couldn't really easily charge, although there were these fascinating trips. Oliver Fritschel, I think he was EV entrepreneur at the time. He completed I think it was a cross-country trip, but there were people who did these amazing trips in early electric vehicles that kind of showed you could just about, get across the country. So it could be done, but it wasn't easy. So I think the infrastructure, the batteries, as we talked about, and then there is one study saying if the electricity grid was just a bit more developed at the time, maybe it would have taken off. But then it was just trying to compete against a moving target. The internal combustion engine was just getting better and better, and as it was mass produced, it got cheaper and better. So it just trying to compete against something that was getting better all the time. And then, as we talked about, the starter motor, and Charles Kettering, I think, invented that. So that kind of changed things. As you said before, then women were big buyers of electrics, and Henry Ford's wife had an electric. But yeah, I think there's sort of a number of reasons. But I do think it is strange why America has ended up a country with these big cars, without there were electric streetcars and things at a time, right? So all that kind of thing was kind of destroyed, and led to kind of suburbs and sort of a driving culture. So there were other avenues, and probably the fossil fuel industry also played a role. Yeah, I mean, I think it's not quite clear what the sort of one reason is, but probably fundamentally you could say the internal combustion car was better and was getting cheaper and was being mass produced, and electrics just couldn't compete.
And certainly not for lack of effort. You mentioned Thomas Edison. He famously iterated, I think, about 10,000 different filaments for his light bulb, and he did the same thing for his
batteries,
famed nickel iron battery. But again, ultimately, the chemistries just weren't there. So it sounds like we're going from kind of the early invention of the battery, Volta 1800, the telegraph powering the first global communication system, with I think it's basically there all seems to be this 30-year lag between invention and mass commercial deployment of batteries. But similar chemistries used to power the telegraphs, and then we get into EVs, which we explored the reasons why they floundered, and then it sounds like there's a time in which we're still using batteries, as you mentioned, probably in absolute terms more and more, lead acid batteries to start cars, some industrial applications, lighting. But the lithium ion revolution, I think, is really key here, and the need to power small consumer electronics. So we could talk about sort of the chicken and egg of that, the demand side pull from the electronics or the supply side response. I guess there was some, just thinking back to my own childhood before lithium ion arrived, there were some more kind of disposable battery technologies. But yeah, maybe we'll start with the use case and then response in terms of the chemistries and technologies that return. So talk about, again, we'll just move through these use cases. If you want to expand it all upon that gap between EVs and consumer electronics, go ahead. But
so EVs never went away. So I think if you look through the archives, there are always efforts going on in Japan before the Korean War, or Ford tried in the 1960s. But anyway, so people never lost complete hope in it. But I think, yeah, that marriage between consumer electronics and the lithium ion battery was perfect, because a number of things happened, which was, you're right, you had the demand, the need. So the early camcorder, I think, used a lithium ion battery. And then, what was interesting was Chinese companies in the 90s started to get into the business of manufacturing batteries, and eventually lithium ion batteries. And they really made them cheaper by using cheap human labor, migrant labor, using low environmental standards, and this is the roots of the big battery companies that dominate today, right? So they have their roots, BYD, CATL, in making batteries for consumer electronics. And why is this so important? Is because they got accepted into the supply chains of big global brands like Apple, Motorola, back then, used to be a big brand. So that kind of gave them the impetus to be globally competitive, right? From China was very poor, right? But became globally competitive. And from that foundation, they then moved into EVs much later when China stimulated electric vehicles. But I think, yeah, the consumer electronics and lithium ion battery can't be overstated, because that's what kind of brought the costs down, gave it a market, right? And then laid the foundation for when electric vehicles came along. And you had this, GM had the EV1 in the late 90s. EV started off with lead acid and then nickel metal hydride, but never used lithium ion. And that was kind of, again, another sort of missed opportunity. And then you had people, Nissan Leaf, and then famously Tesla, moving to use lithium ion batteries. And that was a key breakthrough, just because they could hold enough energy to actually power a car for long enough distance. And they were still very expensive, and that's the genius of Tesla's strategy of selling first to rich people in Silicon Valley, because the batteries were still too expensive. Yes, consumer electronics have brought down the cost, but they needed a further revolution, a further manufacturing expansion to bring them down, to make them cost competitive for electric vehicles. But that was the genius of Tesla's strategy, starting at a high price point, and then eventually bringing them down. But they had the consumer electronics foundation, so that the foundation of CATL, the world's biggest battery company in the world, is split off from ATL, which was making consumer electronics batteries. And that's how we enable electric vehicles, based on that foundation.
I just thought of it now, but I think there's an interesting story in terms of the subsidy regimes and industrial policy that led to China's dominance now as a global supplier. And we have, I think, on the Chinese side, sort of a supply side set of subsidies as part of, more recently Made in China 2025. And as you were just mentioning with the Tesla Roadster, the demand side subsidies in the US. Could you jump a little bit more into the California zero emission vehicle mandates and just the mechanics of how that provided a very strong sort of guaranteed revenue stream to Tesla to take this risk and build what was a very early EV model at a time when there's probably a lot of skepticism.
Yeah, the California market was key, because it's obviously such a big auto market. So that helped push forward plug-in hybrids and then EVs, and then selling the credits obviously to other automakers, which has been good money for Tesla. But I do think is the Chinese market the world's largest EV market, which has actually impacted change on a globally significant scale. And I think they started with small pilot subsidies and government fleet purchases, electric buses, and then seriously subsidizing consumers. But they were actually quite clever with the subsidy policy. It wasn't just buy whatever you want. They kind of first set energy density requirements so that the battery technology could improve, and then they switched to set cost requirements in order to meet the subsidy. So they kind of played it like a conductor. They kind of created this market and shaped it. And of course there were many failures and lots of bad behavior, but essentially they created demand and subsidized the supply, which I think is what you need to do. I think that's exactly what Joe Biden did when he was in power. And also they used protectionist measures. So amongst all that, they had limits on foreign battery companies. The auto sector, you had to have joint ventures before Tesla set up in China. So many restrictions on foreign technology. So all those things combined, they were a very powerful symbol. And then just the powerful strategic impetus, which was you had China importing a lot of oil, making it very vulnerable to what's going on in the Middle East, and to the sea lanes, which are patrolled by America. You had a pollution when I lived in Beijing it was maybe not threatening social unrest, but it was making people very unhappy. And the Communist Party cares about that as well, right? They're not democracy, but they care, and they definitely care about
Regime
unrest,
stability.
stability. And you had this moment where pollution was a really big issue in Beijing and in China. So that also fed into the desire to do it. And then the final reason is they could leapfrog foreign automakers. They never succeeded in producing decent internal combustion cars, and the foreign automakers were making out really well in China, making tons of money selling cars. I just remember always going to the Great Hall of the People for the government meetings, and you just see rows and rows of these black Audis, or I think it was Audis, foreign cars, right? We were just being bought en masse by Chinese government and other people. So all these reasons they could leap that kind of focused China and made it perfect. And now this year, sales of EVs are going to overtake sales of internal combustion cars in China.
And almost all of those, I guess there's people still driving Teslas in China the way they still use iPhones, but it sounds like more and more of those are going to be domestically produced. I realized I sounded like a complete idiot there trying to create this this contrast between consumer side subsidies in America and production in China. Obviously, as you've just outlined, massive consumer subsidies to get this whole industry going, as you mentioned, for very pragmatic geostrategic reasons. Number one oil importer. They've actually managed to plateau despite ongoing economic growth. Very impressive, and speaks to what a national priority has been to try and reduce that reliance and reduce air pollution, as you were mentioning. But let's talk a bit more now, I guess, on that production side. I don't know if we want to call it subsidy or just industrial strategy or coordination. Perhaps we could look at that from the government perspective, but it also, you do a great job in the book of, narratively sharing some biographies, say of Robin Zeng, for instance. He's called the Battery King in China, I believe. So maybe use his story to talk again about the industrial policy on the production side for China to really have gained this dominance away from Japan, which I guess in the early days was producing a lot of the consumer electronics and the batteries.
We can't forget Japan's role, and obviously Panasonic enabled Tesla, so huge role that Japan played, and the Nissan Leaf, as I said. So the characters, I think, you have what I call like clean energy barons, right? So if you look at all the wealthiest people in clean energy, they're probably all Chinese, and these are multi-billionaires now. And it kind of like is similar to the early days of oil and gas, where you had these sort of entrepreneurs. China in the 80s, 90s was a Wild West place, right? I remember going to Shenzhen in the 90s, and it was kind of a Wild West place. And you suddenly had this opening up in the society where people could leave the iron rice bowl, the state sector, and jump into the private market. And, these are entrepreneurial people, clever people. So you had this like unique moment in history that will never happen again, where there's so much pent up energy, poor country, these billionaires in clean energy all had quite hard, poor backgrounds. Founder BYD grew up basically an orphan, or he lost both of his parents, and grew up in a poor province. So you had this opening where places like Shenzhen or southern China, you had this freewheeling capitalist moment in time, and these people took the chance and the opportunity and really ran with it. And that's something that Robin Zeng did. He was working for a foreign company and then set up his own company. They bought a patent from Bell Labs to make batteries. They couldn't get it to work. They worked day and night to make it to work. And then they started producing batteries and got contracts with international companies, and the rest is history. But these capitalist times, capitalist people who made this happen, right? And then and then later on, they moved into electric vehicles with much more government support, much more government subsidy, etc. But they had already built their business acumen, their skill and knowledge in batteries by that point. So you look at BYD, when he went to buy a car company, everyone said, don't do it. All the shareholders, investors said, "What are you doing? Don't do it. You're doing well making batteries." But he had a vision to eventually do electric cars, and he proceeded with it. But they had expertise already in batteries. So yeah, the characters are important because I think we get carried away thinking of countries and what's China doing and what's the US doing, and obviously characters like Elon Musk, like Wang Chuanfu, like Robin Zeng, they also determine and shape history. And I'm quite convinced on this the more I think about it. I mean, think about Edison and Ford and that early attempt to create an EV. That was very much personality driven at that time. Um, and so they do shape and determine history. And I think we think too much of China in terms of the Communist Party controlling everything and subsidizing everything. And actually, yes, they lay the groundwork. They give subsidies, and local governments obviously give industrial parks with dormitories and electricity and all this stuff. But you still have the individual that's decided to do this or do that and make a go of it. And I think BYD, the founder Wang Chuanfu, had a vision of electric vehicles and has one of decarbonizing China, which is quite powerful. And I think Robin Zeng of CATL also has that vision of how can we decarbonize trucking, how can we all these sectors where batteries can play a role. And I think they're driven by that. And of course, Xi Jinping has laid the way with his promise that emissions would peak, and that's kind of set the strategic direction. But they're still powerful individual stories in exactly the same way that Elon Musk is.
So I just wanted to, I do want to jump into mining and the supply chain, which will, I guess, feed as well into a story about the evolution of the chemistries towards LFP, lithium iron phosphate, and now even sodium ion. But before we get into the mining and the kind of global supply chain and the kind of nitty-gritty underbelly of this energy transition, I just want to get a better sense. Again, China was really dominant in this area probably in the 70s and 80s, second largest economy in the world, high-tech manufacturing, leading on electronics. How did China sort of pull that industry in and move up the value chain? How was it able to maybe even coerce Japanese companies to kind of assist in their own destruction eventually?
Yeah, it's a really fascinating story. And I think, again, it goes back to what China was in the 80s, 90s was poor, really came from a poor place. And you had a historic, again, which will never happen again, scenario where you had migrant laborers flooding in from the countryside to work in the cities, in factories, living in dormitories. So it was really, they had cheap labor, they had a vast market, and they're also very good at doing what they do. So I think, they sucked in a lot of foreign companies into China with the promise of, the promise of the market, but also being closer to suppliers as China sort of built out and absorbed all these industries, everything from aluminium to steel to chemicals. Because of China's lax environmental rules and low labor costs, all these industries, China took over and overproduced, and the foreign companies went bankrupt, and China kind of dominated the industry. As to moving up the value chain, I think that was a sort of logical next step. Once you've trained a workforce, you've got skills, you've got consumer demand evolving and becoming more sophisticated. That helped propel up the value chain to a state we see today, where you have Chinese companies like Xiaomi that produce mobile phones and now electric vehicles, high-tech robots. They've massively moved up the value chain, challenging Western companies and producers. So it's a very impressive story, moving from very poor beginnings to moving up the value chain. Now as a result, obviously labor costs are higher, environmental standards are much stricter, and China itself wants to offshore polluting bad industries to other countries. But they have moved up the value chain, which has enabled them to take a leading position in some of these higher value added industries, EVs, batteries, AI now, to all these other industries. So yeah, it's quite impressive, but it still aligns. A big part of the Chinese economy is driven by property, by infrastructure investment, all those kind of old things. So the question is now, how much can the new make up for slowdown in the old?
So, as you're mentioning with steel, for instance, where China is absolutely the dominant supplier now and able to produce through scaling at such low cost and flood world markets and really kind of develop a near monopoly status. We see that in polysilicon and solar panels. I believe that's kind of similar with lithium now, which I think is a good jumping off point for this big thematic chunk of your book, which is, I guess, sort of the four pillars of batteries. And the chemistries have changed, but we're talking lithium, cobalt, nickel, and copper, I guess, just as a way of wiring it all together. So maybe let's talk a little bit about each of those resources. I do want to talk about Dan Gertler at sometimes. I think that's a very vivid character from your book in the Democratic Republic of Congo, but I'll let you kind of steer where you want to take this. I would like to touch on each of those minerals and some of the trips that you made to see some of the again, that sort of gritty, dirty underbelly of this whole battery transition.
So it's interesting because I'm a big enthusiast and interested in clean energy, but the angle I approached the book from was actually the supply chains and the mining and processing, because to scale up clean energy industries, you need to build these new supply chains and you need a lot more raw materials. And I think in my mind, the reason I wrote the book also was it wasn't quite well appreciated that solar panels, wind turbines, batteries, you can't just magic them from nothing, and you're going to need to mine, process, and produce these minerals. It's like the as you said, the underbelly of this transition that is invisible to most people, and especially in the West, because we've offshored so much stuff. Here I am in the UK, we don't see smelters anymore, or other industries or chemical plants. So we're completely divorced from that side of the reality, in a way which people weren't, I don't think, 50 years ago in the UK. So when you look at batteries, lithium, as you said, is a key one, and lithium, lithium is mined in Australia and Chile and Argentina, Africa, but goes to China to be processed and turned into materials for batteries. Cobalt comes from Democratic Republic of Congo, but again goes to China pretty much. And nickel from Indonesia, where it's mined and also processed in Indonesia, and then goes to China. So China effectively sucks in all these raw materials and turns them into useful products. And this also drove Chinese companies to invest all over the world in mining projects to secure supplies of raw materials. And this has had big geopolitical implications, because if you look in Africa, when I went to the DRC, my whole plane was full of Chinese, and there were just Chinese everywhere in the mining area of the DRC. So it's had big implications. Chinese companies have gone out into the world to secure these resources, and that impacts the countries where they go. And they've been big investors in Chile and Argentina as well. So now the West has kind of woken up and been like, well, wait a second, we've dominated the industry in China. You've also secured a lot of the key inputs for these supply chains. So the West feels quite trapped. And then there's rare earths, where China both mines a lot, but also processes a lot and produces the final products. So the book really is driven by, so for a lot of mining companies and the mining industry, the EV clean energy was like an exciting new development, and there was quite a sort of scramble for resources, and a lot of interesting characters investing in these new resources, because suddenly demand was taking off and there wasn't enough supply. So you had a lot of interest in cobalt in the DRC and investments there, and likewise in lithium in Chile. You had a Chinese company come in and buy a stake in one of the main Chilean lithium companies. So a lot of sort of interesting developments, and a lot happened, I felt like, before the West had even taken notice. That's why I wrote the book as well. So again, another example, the same Chinese company bought the best lithium mine on the planet in Australia, Greenbushes. Now it owns a smaller stake, but just came in and did that, right? And before anyone had sort of like put two and two together. So you have a situation where China controls a lot of these supply chains, processes a lot of these minerals, and then produces a lot of the batteries. So if you're looking at who has power in the clean energy world, it's clearly China. But power does shift, and the producers of minerals obviously do have power. If they cut off production, that's quite a lot of leverage. So power does shift in these supply chains, which is another interesting dynamic.
Okay, let's talk Democratic Republic of Congo, and this will stretch back a little deeper in history. This Israeli billionaire, I guess he's son of family involved in probably more of the polishing consumer side of diamonds, but develops a very good relationship with, I believe he might be called a president, but I think for all intents and purposes, a dictator of Democratic Republic of Congo. Whenever a country has democratic in the title, that usually tells you something. But yeah, explore. I love this. I mean, he's a bit of a villain, but I like this sort of character development, and it exposes again, there's an environmental cost. You have artisanal mining in cobalt, horrific conditions. But in terms of that systemic corruption that follows some of these resources, which are so concentrated in certain countries in the world. Let's talk Dan Gertler and Congo Cobalt.
Yeah, so DRC is just a fascinating country with a sad history with resources, where every resource that the world needs it seemed to have at that time. Whether it's ivory, and then later on, for copper, and then uranium for the Second World War. I believe some of the bombs that were used uranium from the Congo, and then copper, and obviously cobalt was mined with copper. So then cobalt, when the electric vehicle revolution came along, and you have people like Dan Gertler, who went to the DRC, quite a brave, sort of bold thing to do. Was kind of just come out of a deadly civil war. It was, again, very poor. A lot of the mining infrastructure that had been there was damaged and needed investment. So from one side, he did actually invest in these mines and build these mines, and he became very friendly with the young president at the time. But then you had a lot of, the people that would take the risk to go there at that time and invest in mining projects, a lot of interesting characters. And what was so interesting about the Dan Gertler story was how he sort of teamed up with Glencore to develop these mines in the DRC. And then when I was following the story, there were a lot of questions about the relationship between Glencore and Gertler, and then how much Gertler had, corruption allegations against him, which he's denied. But all of it sort of came to a head just as the electric vehicle revolution was taking off. So you had this massive potential contradiction, which was, well, who are the guys who are actually getting rich and making money off of the increased demand for cobalt? And what are the sort of corruption allegations? And in a way, that threatened to taint the electric vehicle takeoff, and especially the story about child mining, the terrible conditions that the individual miners work in the DRC. So you had both allegations of corruption, those sort of history, and then the sort of child mining side, the human rights side. So you had all of this sort of coming together and raising real questions about the supply chains behind electric vehicles. So I think these characters, there's as I say, there's the DRC in a way was a place that not many people were willing to go and invest, and these people did do that, but along the way there are allegations about corruption. How did they get the mining licenses that they were given at the time, etc. And then you had the Chinese coming into the DRC, and the Chinese company bought the best cobalt copper mine in the DRC from an American company. So again, it wasn't, underhand or whatever. They actually, they offered a good price and bought the mine, and that's now the biggest cobalt producer. Has overtaken Glencore, biggest cobalt producer in the world. So the DRC is incredibly resource rich. The grade of copper and cobalt, and we'll need copper as well for the electric grid and EVs as well. So the DRC is really at the heart of things, and the big question has always been, how can they actually benefit in the best possible way and not repeat their history of never making money from their resources.
Right. Yeah. What's really struck me about that story, I guess, is, Gertler cozies up to Kabila, and then, probably is providing some financing. I'm not exactly sure what he brought to the table. It sounds like funds to get these war-ravaged mines back online, but is given, very good deals, I guess, on large mining concessions and sells those on. Ends up on a U.S. sanction list, I understand, and ends up getting this big payout, I think, from Glencore, and then royalties guarantees as well. So it's pretty extraordinary.
It's extraordinary
that
because
story.
I think, for Glencore, they kind of got into bed with him, right? And they needed him, and they couldn't just dispose of him as quickly as perhaps they had wanted. And even you've seen later, I think he was pardoned by the former Trump administration. There's even been a sense that maybe the West needs him, to compete with China.
With China,
so
interesting.
That raises a question of like, what kind of deals are we willing to do to compete with China and Africa? So as I say, what's so interesting about going there when I went there was the presence of Chinese on the ground, and then these big multinational companies, Glencore, a few others. So, it's not like the West has no foothold there, but definitely the Chinese are extremely dominant. And that goes back to the fact that they're the main demand. So all the cobalt goes to China. So of course, you had these entrepreneurs coming from China to the DRC saying, well, let's secure, why should we buy from international traders? Let's go and secure our own resources.
Let's move on to nickel then. I think you went to Indonesia. Describe the mining operations there and the kind of ecological toll that they have going after, I believe it's the laterites, or the kind of exact ore they're going after.
Yeah, so nickel is key for Indonesia. It's incredibly rich in nickel, but what Indonesia did was ban exports of raw nickel a few years ago, and then say if you want to get the nickel, you have to come build processing. And the Chinese really took up this offer with great gusto, again, because they needed the nickel for stainless steel production in China. So you had huge stainless steel producers in China, and the main use of nickel is stainless steel, not batteries. So they came to Indonesia, invested in these big industrial parks. It became part of the Belt and Road Initiative, Xi Jinping's big strategic initiative. And then when electric vehicles started coming along, then they sort of built plants to process the nickel into the type of material you need for electric vehicle batteries. But there'll be a number of issues with the production in Indonesia, so labor issues, labor safety, but also this is a sensitive, biodiverse environment. Initially, there was talk about putting mining waste into the sea. They don't do that, but there's still these are sensitive, biodiverse environments, and there are still questions about the impact on the environment. I mean, to be honest, like producing nickel for batteries can have a much lower carbon, or does have a much lower carbon footprint than producing for stainless steel. But again, the carbon footprint is not everything. You have to also look at what's the impact on the broader environment. So again, this just raises questions about the cost of these supply chains that we're building, and how can we improve them? How can we make them better? Because Indonesian nickel production expanded by so much that it effectively pushed other producers out of the market, and potentially more sustainable production in Australia or Canada has really been challenged by so much supply from Indonesia. So again, I mean, yes, stainless steel is driving it, but again, because an electric vehicle is a green product, there's much more focus and I would say opportunity to kind of improve these supply chains, and improvements have been made with some solar energy, other energy, but still, this is a processing industry where often they use their own coal-fired power plants on site. There are questions about the impact on the environment as well.
So whereas in Canada, up in Sudbury, we have a big Mere impact that delivered a whole bunch of nickel and a nice concentrated deposit. We do underground hard rock mining. How does that compare to the kind of mining? Like how does the landscape physically change in Indonesia when they go after their nickel?
So nickel laterite is much, they don't need to have big, deep mines. So the mines are much closer to the surface in Indonesia. So that they're not like big, deep underground mines. So again, that raises questions about more disturbance to the surface of the earth, potentially more runoff into the sea or into the rivers, etc. Than a big sort of deep underground operation. And Indonesia's trying to, or has tried to control some of the nickel mining with a quota system. So I think they've even been importing ore from the Philippines to make up from lack of supply from Indonesia. So they've been trying to control the nickel mining industry.
There's a little bit of, that doesn't sound like quite an OPEC type cartel, but Indonesia seems like such a dominant low cost producer that it's able to, and I admire them bringing refining there rather than just sending it off to China. But obviously some big environmental costs. So in terms of getting back to Robin Zeng and CATL, I would pronounce it cattle, but I'm probably there's probably another way to pronounce those initials. But we have new chemistries that are coming along. So what was the relevance of cobalt and nickel in earlier, and I guess there's still ongoing lithium-ion batteries using it. Why do we need nickel and cobalt, and do we need nickel and cobalt in these lithium-ion batteries?
Yeah, that's a good question. Yeah, so when we look at lithium-ion batteries, in most electric vehicles today, there's either two chemistries. There's NMC, nickel, manganese, cobalt, or there's LFP, lithium iron phosphate. And it's kind of a geeky story, but essentially, it has quite big impacts on the planet which chemistry we choose, because NMC, you need nickel and cobalt, as we've talked about, and manganese, and the LFP, lithium iron phosphate, you don't need those minerals. So obviously you don't need the mines, or obviously you need for other applications, but not for the EVs. And initially, everyone thought NMC would dominate because it's higher energy density, so it can store more energy, for its weight or its volume. So obviously for an EV, that's critical, right? You want to use smaller batteries as much as you can to get as much range as you can. But then the lithium iron phosphate chemistry is cheaper and safer, and the Chinese companies basically managed to improve the energy performance by taking advantage of its safer properties and kind of physically packing it in different ways. So getting rid of battery modules, so you don't need so much protection around the battery. And now what they do, which is cell to car, so actually building the battery cells into a structural part of the car, becoming part of the car. So they have actually, it sounds minor, but it actually has increased the energy density of the LFP batteries and made them, so you can get a better range for the car. So just to conclude, that's kind of made it possible to use batteries with less raw materials that are cheaper for most people's electric vehicles and get a decent amount of range. And that's what's happened in China. And 80% of the market now in China uses LFP batteries, and pretty much all energy storage. So the big container sized batteries that you use for electricity grid, they're all LFP as well. So I think the forecast demand for copper and for cobalt and nickel that people previously had for EVs, that's much less now because of this change in chemistry. So it's had a big impact on the demand forecast for those minerals. Now, there is a big question about the US market or the North American market, where range may be much more of a priority, that you still need the nickel, manganese, cobalt batteries. But again, there are shifts there where people are using more manganese, for instance, and maybe less nickel than was previously thought. So there are changes within that chemistry as well. I mean, the battery market is constantly evolving. There's new approaches, but everything's a trade-off, right? So you what do you want? Do you want performance? Do you want cost? So all these trade-offs. But fundamentally, I think China, what's happened is so significant because they managed to bring down the cost of electric vehicles to enable mass market penetration and really make a difference on a planetary scale. They're the biggest car market anyway, before not even taking into account EVs. So they've been able to bring the cost down and improve the performance of these batteries to make it workable for most people. So that's the kind of key thing. But again, also you need charging infrastructure built out. They've pioneered battery swapping. So again, they've also worked on the improving the charging experience for consumers that perhaps reduces some of that range anxiety. Whereas in the US, I don't know. I mean, it's well, the administration hates EVs at the moment, but there is the deeper sense of range anxiety probably than there is in China and Europe.
Distances are longer for sure. In terms of lithium on our sort of tour, we'll leave copper aside because we covered that elsewhere. But in terms of lithium, I mean, this is a very common element within Earth's crust. I guess there's areas where it's concentrated that you visited. I think both Chile, Atacama Desert is one of the driest places on Earth. I've had the privilege of being there a couple times. Really extraordinary landscape. Also Australia. It seems like the bottleneck is not so much in terms of the resource availability. Certainly, if demand is going up exponentially, but mines open sort of on a more linear function, there might be a supply gap there. We saw the price of lithium jump from, I think, 8,000 to 60,000, down back to
80,000. Yeah.
So things just went absolutely bonkers for a few years there. But would you agree that the bottleneck is more in the refining of the mineral? Because it seems like moving to this LFP chemistry, we've removed a lot of the bottlenecks in terms of particularly how much we can scale. And we're talking about soaring EV demand, but as we get into grid scale storage, the question is, how much can we add? How fast? And California, it's incredible. I think they have 15 gigawatts of instant capacity with 4-hour storage, like 60 gigawatt hours, and they're really able to knock out a lot of their gas peaking fleet. So if batteries really do price down and there's no kind of material limits on them because of simpler chemistries, and maybe getting into sodium ion, that becomes even easier. This is an extraordinary story.
It's a really good point. So if you think about battery factories, you've got the cost of energy, human labor, but robots are doing most of the work. You're fundamentally, energy is key because they use so much energy, but raw material, you're also limited by the cost of raw materials. So you're right, the actual price of the raw material is a limitation in terms of bringing the costs down even further. Or another way to lower costs is increase energy density, obviously. So if you think about solid state batteries or whatever, so you're storing more energy for the same amount of material. That's another way to do it. But you're right. So the bottleneck for something like lithium, and indeed all mining, is it's really just a mismatch in terms of the amount of time it takes to build a mine. Can be over 10 years easily, and then there's sort of fluctuations in demand. So if there's a sudden spike in demand, obviously you can't just build a mine tomorrow. And likewise, when you're building these mines, you have a forecast of demand as well, right? And you have a forecast of price, or the price that you need or you hope for. So there's quite a sort of mismatch in terms of and also the inability to forecast the future, right? So no one knows what the price is going to be. No one knows what the demand is going to be. So you had demand suddenly coming up and lithium couldn't meet it, so price spikes, and then that spurred investment and accelerated projects. When they came on stream, then the demand growth had cooled down, and then there's oversupply. So that's a classic example. So it's not really the limitation of the resource in the ground, is more the timing mismatch. And then you add to that policy uncertainty, right? So Trump administration coming in 4 years, then someone else coming in for 4 years. So it's very, very hard to forecast demand. So, miners, the best strategy is go for the lowest cost project that would be okay in pretty much any scenario. So I think for lithium, it is abundant. There's plenty of resource. It's just a matter of getting the investment to develop the projects that won't create a bottleneck, because these mismatches can be quite serious, as you said, with the lithium price going up to 80,000. Spiking so much, it increases the battery cost. It creates all sorts of issues in the supply chain, even availability issues. So often it's not even a cost issue. It's like, can you get it? So that's also something to be concerned. So we want to try and avoid that, because it actually sets back, or can set back, production. So yeah, it's about trying to get an investment now into the projects that can meet the demand for energy storage and electric vehicles in 2035 or 2030s. So that's what we need. But obviously, in a low price environment, investors don't invest, and there isn't as much capital to invest. So it's fundamentally an issue of mismatch. And I think what the Chinese companies do quite well is trying to break this cycle by investing in periods when the price is low, sort of investing against the cycle. So, buying a good asset when prices are low and people are willing to, or people are not interested in it anymore. So, yeah, so that's something the Chinese companies do. But the other thing that China tends to do is push prices lower. So they have vicious internal competition. So you see big periods of overinvestment, which we've just had in clean energy over the last few years, where everyone's investing, everyone's competing, everyone's eroding each other's margins, and the price falls. But it means that foreign companies can't compete very easily. So we've had a big period of that in China over the last few years, which has made it even harder for foreign people outside China to finance mines, to finance processing, etc., because you're dealing with oversupply situation.
So the cost drop off we've seen in batteries has been extraordinary. $1,200 per kilowatt hour down to, I think, $140 per kilowatt hour over about 12 years, from 2010 to 22. I was just looking at what that means for like a big American style good range EV with, well, I'm not sure if 60 kilowatt hours is even considered that, but just with 60 kilowatt hours, we're looking at, 10 years ago, that price of just the battery would have been $72,000. And now, again, that pretty extravagant battery down to $12,000. It used to be said the battery was the main cost of the car. And I guess that's sort of changed as the battery's gotten so cheap. But in terms of that cost down, it was interesting you were talking about sort of what some of the hard basements are with lithium production. That applies to batteries as well, obviously, the energy costs,
Yeah, and then
labor costs, et cetera.
battery swapping, you take the cost of the battery out of the car. So that's also an interesting model. And that's another way of getting the cost of the EV down in China. You lease the battery, you don't buy the battery. So
In terms of the move on towards sodium ion technology, so I understand less energy dense, but there are actually some cars that are being produced in China now with sodium ion, again, where range isn't such a big deal, or just urban cars. What are the challenges of scaling that up? Can you build these in the same factories? Like, can you take advantage of the same infrastructure? What do you forecast there in terms of the expansion of sodium ion?
So I think it's been, so it is expanding in China, but obviously compared to lithium ion, it's a fraction of production capacity, but it has some advantages. So it works better in lower temperatures. So if you think of Canada or provinces of northern China, northeast China, it goes down to -30, -40. So sodium ion can work better. So it is actually meeting a market niche, a demand niche. And I think CATL is combining sodium ion with lithium ion in one car. So you may be able to get the best of both worlds. But the challenges are with it, like with any new chemistry, it starts off, it's too expensive compared to the massive scale we have now in lithium ion batteries. So how do you compete? Then the price of lithium has been very low. So again, where's your cost competitiveness if your rival technology has the manufacturing scale, cheap cost of lithium, all these other advantages, right? So what's the incentive to develop sodium ion? But again, as I say, I think the low temperature benefit, and then eventually the lower cost issue, because the raw materials are cheaper. Potentially you could get much lower costs, down to $20 a kilowatt hour or something. So yeah, eventually, and especially for energy storage, you want the cheapest possible cost possible. You gotta compete against power, the electricity grid. We need lowest cost possible, because we need to deploy a lot of these batteries. So yeah, I think sodium ion has potential. It's just a question of how do you overcome that competitive challenge, like with any new chemistry. But I think in China maybe they will do that, because for someone like a CATL, they can afford to take losses, or afford to usher in a new chemistry with the knowledge that it will eventually get cheaper. There will be a payback further down the line. But if you're a sodium ion startup in the West, for sure, it's challenging.
So I guess just in closing, there's a lot of anxiety in the West for some of the reasons that your book really lays clear in terms of dominance, really full spectrum dominance across mining, refining, processing, and even, again, the value out of these finished products. We do see this divergence of the U.S. kind of as into a petro state with the fracking revolution, and really leaning into that hydrocarbon advantage, and China out of necessity becoming an electro state. There is that sort of divergence that's opening up there. But there are certain technologies which both countries are quite interested in, I think, namely drones coming out of the Ukraine conflict, where battery production, I mean, we're going to do a whole other episode of rare earth minerals and minor metals with David Abraham coming up soon. But just talk a little bit about, the kind of, you can decide whether or not you care about decarbonization, if you have the luxury of bountiful hydrocarbons. But how is the rubber meeting the road in terms of geostrategy and defense applications when looking at this Chinese dominance of not just, again, adding on to that list of full spectrum dominance, most of the patents being filed on battery technology, probably 100 to 1 are in China right now. So the innovation is also there.
Yeah, I think it's a challenge for the West, and I think that the Ukraine conflict has shown the importance of drones, which you mentioned, which obviously China dominates production of, and batteries as well. So I think it is a real challenge for the West, which is how do we cut China out, but how do we even just reduce China's dominance by a little bit, so that we can diversify just a little bit, right? So again, in rare earths, that's happening. The US government is, amazing really for Republican Party to take an equity stake in a company, pick a winner so blatantly. You would think it goes against all their beliefs, but choose a winner, support it, throw government money at it. But it's driven by that national security imperative, which is we've got to try and diversify a little bit, so we're not so beholden to China. And China has used its rare earth weapon this year, and what everyone used to talk about what would happen if they did. Well, they have used it, and what's been the impact? It's been quite damaging, right? And even car production has stalled in some cases, and Trump went back to negotiate as a result. So it has worked for China this year. So that only accelerates our realization that we need to diversify for national security reasons. But I think the decarbonization agenda might be set back in the West, but essentially there's crossover, right? You can either frame it all as national security, or you can also frame it as decarbonization. But essentially, these are technologies that are going to be important in the future. mainly civilian, but because of that, they're going to be important in military too. And call it what you want, but we should develop some of these industries ourselves. Otherwise, we are going to be beholden, and we saw the effect of that quite clearly this year, that it can be quite damaging. And we've also have a history of dealing with OPEC, which is a classic cartel, right? So we know how damaging this kind of behavior can be, and how vulnerable we put ourselves in the position of. So I think, to me, I think we need to move away, perhaps, of associating clean energy with the left wing, or I think that's been extremely damaging, and it's also just not true. As we've talked about batteries coming, no one thought 100 years ago, oh, this is so left wing and hippie-ish. This is just not true, that the clean energy is such a association with left wing and hippies. It's just smart strategy that these are industries of the future. We need power, we need cheap energy. Clean energy can provide that. We need batteries because drones, whole loads of other things. So I think we can reframe it to appeal to people if it hasn't worked in the past, which clearly it hasn't worked to a big degree. But essentially, we're talking about the same thing, which is building up industries in the West, and not just having service-based economies and offshoring so much to other countries around the world. We need to have some sort of industrial resilience.
Well, amen to that, Henry. It was a real pleasure having you on the podcast. I know you're looking after your kids today on a bank holiday, so we'll let you get back to them. But very much appreciate you taking the time today.
Thanks so much, Avi. Really enjoyed the conversation.
Looking forward to the next book. So here it is, Volt Rush. Oh, that's not a very good focus. Highly endorsed by Decouple.
Thank you.
Okay, all the best. Take care. Today's episode was made possible through a generous donation from the Xerxes Foundation and from listeners like you making pledges on our Substack. If you'd like to join the tribe, please do head over to our Substack, smash that pledge button, or if you would like a tax-deductible receipt, you can hit the donate button and make a contribution to our fiscal sponsor. We genuinely appreciate your support. It is only through your generosity that we are able to continue to offer energy literacy on demand.